Hi dear students, today let us start with the first section of our very first class of Mathematics, chapter number 1, Real Numbers. It's actually the continuation of the chapter Number System which we have studied in our 9th class. Just let us recollect what we studied in our 9th class. We have studied about number system. We studied about real numbers mainly. Number system was classified into natural numbers, whole numbers. Then we studied about positive numbers and negative numbers. And these positive numbers and negative numbers all together we will see it's integers, right? Then we studied about real numbers. Especially there was a particular part which we studied in our 9th class. That's rational numbers and irrational numbers. Let's just recall what is rational numbers. The numbers which can be written in the form p by q, where p and q are integers, and the denominator part, that means q, should not be equal to 0. That typical type of numbers is what we call rational numbers. In simple words, we can say if you can express a number in the form p by q, means something like a fraction, which you have studied in our small classes, junior classes. If you can express a number in the form p by q, that's what we call rational number. Then what is irrational? Yeah. If you can't express, right? If you cannot express any number in the form p by q, where p and q are integers, and this denominator part, that means q should not be equal to 0. That means p can be equal to 0, right? Q should not be equal to 0 because divisibility by 0 is not possible. There is not even multiplication table for 0, right? That's it. So these are the topics which we studied in our 9th class. And in this class, in the very first class of our maths, especially in this 10th class, we are going to study much more deeper about number system. Especially where we are going to use the theorems which we have studied in our 9th class. The application, that is the main thing which we are going to study in this chapter. In this chapter, mainly we are going to study about two topics. Number 1, Euclid's division algorithm. Number 2, the fundamental theorem of arithmetic. So what is Euclid's division algorithm? You are familiar with the term algorithm, especially when we are studying a computer. You may be familiar with that term algorithm. So what is algorithm? Algorithm means it's a well-defined steps, or it's an order to get a solution. A well-defined steps of order means if you are defining some particular steps so as to receive the solution of a particular given problem, those steps which are written in a particular given order is what we call algorithm. So here, division algorithm of Euclid, Euclid's division algorithm. Now, I think you got a small idea about something, right? You are going to, that means we are going to study about some steps. Yeah, that's right. We are going to study about some steps. And you must understand these steps one by one. Means exactly the very next step, and then the next step, and then the next steps, which leads you towards obtaining the solution of a given problem. Now, this Euclid's division algorithm, it deals with the divisibility of integers. Normally, you just know it. Just imagine that there are two, just imagine that a and b are two positive integers. While dividing a by b, you get r as the remainder. Now you can express this particular given ratio because already you know when you are studying in your small classes, I mean 6th, 7th classes, we have studied like this. Dividend is equal to divisor multiplied by quotient plus remainder. You know it. Dividend is equal to divisor into quotient plus remainder. You have studied that one. So same thing we are going to use here. The same application we are going to use here to find the HCF of any given two numbers. That will be followed by some particular step. We will be following some particular steps, and through that steps we will be doing that one. So that steps are what we called the algorithm. And as Euclid made this one, in honor to him, we will name it as Euclid's division algorithm. Now hope you understood about that. And the second thing which you are going to study in this chapter is the fundamental theorem of arithmetic. We have studied about composite numbers, right? What is composite numbers? Composite numbers are the numbers which are having more than one factor. Any number, if it is having more than one factor, that typical number is what we call a composite number. For example, 8. What are the factors of 8? 1 itself is the factor of 8. Then 2 is a factor of 8. 4 is a factor of 8. 8 also is the factor of 8. Means in these tables you can see 8. That's the meaning in simple ways. So you can see for 8 there are plenty of factors. Similarly, if you are taking any number and that number is having more than one factor, then that number is what we called a composite number. Hope you understood that one, right? Okay. Now, what is fundamental theorem of arithmetic? That's what my question was. The fundamental theorem of arithmetic means every composite number, if you're taking any composite number, it may be any number, but it should be composite, that's it. If you're taking a composite number, that composite number can be expressed as the product of primes. If you're taking any composite number, and if you're factorizing it, you will get the multiples, right? And if you're multiplying all the terms together, that means if you're taking a composite number and splitting it, you will get plenty of prime numbers. Means all the prime numbers together, if you're multiplying them, that will be a composite number. So we are going to use this method, or we are going to use this theorem in this chapter. And it deals in this chapter to prove the irrationality of numbers. In 9th class we studied that root 2 is an irrational number, root 5 is an irrational number. Like this we studied, right? We just studied and went, that's all. But in this class we are going to prove it that those things are irrational itself. And for that one we are going to use this theorem, which is what we call the fundamental theorem of arithmetic. That means, especially where we are using this one, see, if a fraction is given for you, you know that any fraction can be converted into decimals. While you are converting a fraction into decimal, what happens? The decimal can be terminating. We studied it in 9th class in the very first chapter, right? It can be terminating. Or case number 2, what is the second case? It can be non-terminating. In non-terminating, again there are 2 more cases. What is it? Case number 1, it can be non-terminating and non-recurring. Means non-terminating means not going to stop. Non-recurring means not repeating. It's not going to stop, not going to repeat. That is one case. Another case, it's non-terminating but recurring. It's not going to terminate, not going to stop, but it keeps on repeating the numbers. So that's what we studied in our 9th class. So collecting all these things. See, in 9th class, if you want to understand whether a given fraction is terminating or non-terminating, what should you do? What did you do? Just remember, you will take the division and you will start the long division method, and while dividing it one by one, finally after some successive division, long division methods, you will come to a conclusion that this is terminating, or this is non-terminating, or this is recurring, non-recurring, like that. After long divisions only we will get the solution. But in this chapter, just by seeing the denominator part, we will conclude whether this given fraction is terminating, or whether this given fraction is not terminating, or whether it is non-terminating and non-recurring, or non-terminating and recurring. Just by seeing the denominator part. That's what we are going to study in this chapter. The first thing which we have to study is Euclid's division algorithm. While studying this one, you must know about Euclid's division lemma. Now, what is lemma? As I said, what is algorithm? You understood what is algorithm. Now tell me, what is lemma? What does it mean by lemma? Lemma means it's a proven statement. Means it's already proven statement. Something is proved already. We know it. And that proven statement we are using to prove another proofs. If you are using a proven statement, means an already proved statement which is used to prove another statement, is what we call lemma. So what is the lemma here we are going to use? We are going to use, I told it earlier, that a dividend is equal to divisor into quotient plus remainder. Okay, that's the lemma which we have already know, which we know it already, right? That lemma we are going to use in this chapter to find the HCF of any given two numbers. And by using that lemma, we are going to follow some steps. That steps are so important. It's the Euclid's division lemma states that for any two positive integer a and b, there exists a number, there exists another integer q and r such that a is equal to bq plus r, comma 0 less than or equal to r less than b. That means if you are taking any two numbers a and b, there will be another two numbers q and r such that it will follow this expression. And after the comma, it holds 0 less than or equal to r less than b. What does it mean? It means that the remainder will be always lesser than the divisor. Always the remainder should be less than divisor. That's why less than b, less than b. But in the left hand side, you can say less than or equal to. That means it can be 0 or it can be more than 0. It can be 0 or it can be greater than 0. Okay, so remainder stands in between 0 and the divisor. Here it is b. Okay, that's the meaning of that one. Keep this in mind. It's very important because when you are dividing something, if you got a remainder which is bigger than the divisor, then you have done something mistake. That's very fast we can understand that one. That's a theorem actually. We can understand that. By that one we can understand whether we are doing anything wrong like that. Okay, so that is what we call Euclid's division lemma. And by using this lemma, we are going to follow some steps. What are the steps? If two numbers, just say c and d, two numbers are given, two positive integers are given, and you have to find the HCF of these numbers. So you can write this in this formula. By using Euclid's division lemma, we will mention the c and d like this. C is equal to dq plus r, where 0 less than r less than d. That means if you are taking a number c and d, forget not, in these two numbers, c should be the bigger number. Always take the bigger number out, then we will say that number is equal to. Okay, this is very important. You have to keep that in your mind. Every time whenever two numbers are given, you have to select the biggest number. The biggest number you have to take it out. Then you will say c. Either to c here, c is the bigger number. So c is equal to dq, d into q plus remainder r. And then how can we find HCF from this formula? Just check out the remainder. If the remainder is 0, then definitely your divisor should be the quotient which you are getting. That should be your answer. That will be your answer. But if the 0 is not, if the remainder is not 0, if the remainder is not 0, again and again you have to follow these steps with d and remainder. Same steps again you have to do with the d and remainder. Again you have to divide the remainder by this d. We will follow the steps. When we are starting the exercises, you will get a much clear understanding about this lemma. Okay, so very fast, let us get into the first exercise of the very first chapter, exercise number 1.1, question number 1. Here goes the question. What is the question? Find the HCF of 135 and 225. 135 and 225 by Euclid's division algorithm. So here you have to follow the algorithm, right? Let's start it. Now, in these two numbers, what was the first thing which we have to remember? I told you. What's the first thing? The first thing means we have to select the bigger number. Tell me which is the bigger one? 225. So let us start with 225. 225 is equal to 135 into how much times? 1, right? Only one time. So 225 is equal to 135 into 1 plus what is the remainder? 90. Okay. Is the remainder 0? No. So that means again you have to repeat. Now where you have to repeat? In which number you have to repeat? You have to repeat the same process by using this 135 and the remainder 90. You have to use those two numbers. Now 135 is equal to, now bringing down this 135 we will write 135 is equal to, come on, by 90 you have to multiply, by 90 you have to divide, right? That's what I told you. So by 90 when you are dividing, tell me 135 is equal to, what will come? 90 into how much times? 1. 90 into 1 plus what is the remainder? Now it is 45. You got the remainder 45. Is it 0? No, it's still not 0. That means again you have to continue the process. With which numbers? Now here is 90 and by 45. By 90 and by 45 you have to continue this same process. Start it. 90 is equal to, tell me, 45 into how much times? 2 times, right? 45 into 2 plus what is the remainder? 0. Oh, you got 0 as the remainder. That means you have to stop it here itself. I told you, when you are getting a remainder as 0, you have to stop right there. We have reached the final step of our solution. Now it's just a bit of time to select our HCF. Now let us go to select our HCF. Which is our HCF? Yes, 45. This 45 will be the HCF of the given numbers 135 and 225. Hope you understood. Let's go to the next question. Question number 2. Find the HCF of 196 and 38,220. Which is the bigger number? Very fast you can say, right? Obviously 38,200, it's a big number. Take that number. 38,220 is equal to 196 into how much times? Very fast, we can't calculate. Let us do it on the work area. Now, while doing, how much it is? You got it. How much it is? 196 into 195. Then what is the remainder? It's 0. That means in a single step itself, the remainder became 0. That means that number was totally divisible by 196. While division, you understood that one. You got the remainder as 0. So when you got the remainder as 0, do you want to go to the next step? No need, right? There is no need. You will stop it there. Don't get amazed when you got the answer in the very first step. Sometimes it happens like that. In this question, it happened. So here, we got a 0 as the remainder. So there is no need to go further ahead. We will stop it right there. And now, as we got the remainder 0, tell me, what will be the HCF? That is 196 itself. So the HCF of 196 and 38,220 is 196. We will write it as HCF of, within brackets we will write, but we will read it as HCF of. HCF bracket, like that we will never read. HCF of 196, 38220. 38,220 is equal to how much it is? 196. Clear? Question number 3. Find the HCF of 867 and 255. Same method, right? Choose the bigger number. 867 is equal to, tell me, in 255 how much times it comes? If you don't know, you can just divide it on side, okay? There is no need to memorize these big numbers. There is no need. It's not possible at all. You just divide on the side and you can understand that how much times it comes. 3 times. So 255 3 times plus what is the remainder? 102. Forget not, your remainder right now is lesser than the divisor. If it became a bigger number than your divisor, then forget not, you have done a mistake. Like that you can understand, because if you are studying all the steps and going ahead, some of them may be simply doing like this and they will get any remainder, they will bring that remainder down and then again they will go further. You will get the wrong answer and sometimes it just goes on. You will never going to get an answer perfectly. You will be totally messed up. So that's why this is the hint. In that particular point itself, you have to understand that you have done wrong. Okay, that's why I remind it again and again. That's why I'm reminding it again and again. Okay. Now, here you got 102 as the remainder. So, as the remainder is not 0, we will have to repeat. Now, next number. What is that number? 255. 255 is equal to, tell me, what's the remainder? 102. So, 102 into how much times? 2 times. 102 into 2 plus what is the remainder? 51. Right? You got 51 as the remainder. Now, next one. Again here, remainder is not 0. So, we have to continue. Let's continue. Next step. 102 is equal to, tell me how much times? By 51 you have to do. Means every time you have to divide it by the remainder part of the previous step. Forget not. So, here the remainder of the previous step was 51. So, let us divide it by 51. How much times? 51 into 2 plus what is the remainder after that one? 0. That means 51 2s are 102. Yeah, it's totally inside that number, right? So that's why you got the remainder as 0. When you get the remainder as 0, what should you think? Your steps are over. No more further algorithm. Keep it there. Pens down. It's over. Now what? Now you are very near to your answer. Now the only thing is you have to choose which is the HCF. Now here, which is the HCF? 51. This 51 will be the HCF of these two numbers. So how we will write? HCF of means within bracket. HCF of 867, 255 is equal to 51. Even though I said comma, we will never say like that. When we are pronouncing it, we will say HCF of 867 and 255 is equal to 51. That's it. So this is how you have to use and understand the Euclid's algorithm method, means the Euclid's division algorithm. So like this, following the steps one by one, if you're following the steps, by that steps you can come to the HCF part without finding it in another way. Means we already studied in our 9th class regarding prime factorization method. In that method also we will find the HCF, but here it's not applicable because specifically it is mentioned that you have to find the HCF by Euclid's division algorithm. If it is mentioned like that, you cannot go to any other method and find the same answer. You may be getting the same answer, but if you want to get the good marks or the allotted marks, then you have to follow the instruction. You have to follow the same steps. You have to follow the same algorithm. So this is what we called Euclid's division algorithm, and we are applying here to find the HCF of any two given numbers. Hope you understood. Next, let us study about the fundamental theorem of arithmetic and its application. Next question itself, we are going to apply that one. Let's go to the next question.